So my name is Anas Itani, and I am a postdoc at the University of Alberta and an academic instructor for 4 courses. I'm presenting today the research or project of my students, Raymond, Luka, and Parmida, where we did a scaled-down simulation and analysis of on-site robotic fabrication and construction, but not on Earth, on the moon. So this project was born from a call-out done by NASA R&D, where they want to build a project called it's called Project Elevator to the moon, or more accurately, Lunar Space Elevator. And this Lunar Space Elevator is a proposed transportation system they wanted to establish between the moon and a point in space where they want to make a tunnel. So this will be good for transportation of materials and goods and so on. And this will reduce the need for rockets, fuel, and reduce gas emissions, basically. So on-site robotic fabrication has been explored in recent decades and offer many benefits. Reduction in transportation cost and emissions, enhanced flexibility, accuracy, and speed in construction, flexibility in design that allows customization and easy site transportation also. Lots of literature review was done on this topic, and this also enhanced our course material that we teach at the U of A, which is the first course in Canada about robotics in construction that include bricklaying, precast, light gauge steel, mass, light timber, and so on. So here we did a literature review on where the application of on-site robotics, which is mostly off-site in the factory. And here Wagner proposed an on-site robotic platform for timber assembly and evaluated its feasibility with a semi-industrial production case study where it built on the site some modules and then transported and then assembled on site by forklift. Others investigated the addition of additive manufacturing as an asset where brackets can be made and formed, which allowed for a complex facade shape, especially in architectural building that is now getting more complicated. So the objective of this is to develop the space tunnel or elevator, and this here is the structure of it. And this is composed of a pentagon shape, a box, which can be assembled and fabricated in space, where you can send a 3D printer, and the 3D printer can coordinate with a robot, pick and place, assemble, and so on. So the goal is to simulate a downscaled on-site construction to build a complex pentagon shape bridge structure. So the construction material was done in the lab, with a budget of $200 for our students. And here they did an additive manufacturing brackets designed on SolidWorks, then transported to a 3D printer, polystyrene foam beams, both from Home Depot, and then cut to shape. 2 UR5e robots, Universal Robots, meant for educational purposes, where each robot is equipped with 5 kg, 1.5 meter reach, and it have an end effector of a camera, 4 torque sensor, and a gripper. The assembly platform also was fabricated, which is, we call it the rig, where we can build our form. And we used an in-house software developed during my research called RobBIM. And this software is unique because it only tackles modular construction or offsite construction. Why? Most of the softwares, which is can be paid or free, it does target only one thing, maybe assembly or motion. Here we combine the 3 series. So first we have an assembly plan using fast algorithm. Then we have a scheduling plan for the assembly plan. And then we have a motion plan using a hybrid A-star RRT star algorithms that will enhance a full package for this software. So as a result, here we compact the assembly platform is configured for rapid production on site. So it's a repetitive assembly. And the brackets are made from 3D printed, so it's easy to fabricate. It improves repeatability, and the brackets don't shift during assembly, which is very important for accuracy because we have a very small tolerance. So this is done through many steps. First, assembly of the rig, and then we put the formwork, then we have the stacking, we build the second level, the third level, then it is transported to a vertical module. Here we have two robots arm working in tandem. One's called Mighty Arm, one is called Armstrong, and they work in with a coordination with each other using sensors and camera. So the fabrication, to test the fabrication productivity, because each time that you repeat the test, it gives a different result. Here we did it on 5 runs, and the average was 99 seconds per assembly, and 71 for the lateral beam and 91 for the pentagon shape. So it is 10% plus minus as a variance. So lesson learned that the concept of offsite fabrication and construction has a potential for future constructions. There's limitations, which here we have robot-human collaboration. There are rooms for improvement, where here we can integrate simulation tools such as BIM, and future research is necessary to develop the concept and evaluate the study. We won the 3rd prize in this competition, and thank you for listening, and we are open to any questions.